This is Julius von Meyer. He developed the law of conservation of energy, which states that energy cannot be created nor destroyed, only transformed from one form to another. If we were to look at some examples of this, the first example that we're going to use is the flashlight. So we're going to take the chemical energy that is in this battery, and we're going to convert it into electrical energy that can be used by the flashlight. The flashlight is going to convert that electrical energy into radiant energy by lighting the flashlight, or lighting the light. Other examples of this are the light energy being transformed into chemical energy by this carrot so it can grow. Another example would be the electrical energy from the outlet being transformed into thermal energy by the heating element. Some more examples include the chemical energy in the food can be converted into mechanical energy as we move and jump and ride bikes or whatever it is we do. And then lastly, the chemical energy in the gasoline is used to move the car, so the chemical energy is transformed into mechanical energy in this example. When we look at temperature scales, we have the Celsius scale, the Kelvin scale, and the Fahrenheit scale. So everybody knows that the freezing point for Celsius is 0 degrees Celsius. And everybody knows that the freezing point for Fahrenheit is 32 degrees Fahrenheit. We also know that for boiling, that at Celsius it's 100 degrees, and at Fahrenheit it's 212 degrees. But the Kelvin scale is the one that we are not familiar with very much. And freezing for that is 273 Kelvin, and boiling is 373 Kelvin. So if you notice that the Celsius and the Kelvin scales, when you go from one to the other, it's a 1-to-1 scale. So there's no multiplying or dividing, it's simple addition and subtraction. Absolute zero is a theoretical number where there is no molecular movement at all. So it's 0 Kelvin. Converting temperatures, when we're going from Celsius to Kelvin, we're going to add 273 to our Celsius number. And when we're going from Kelvin to Celsius, we're going to subtract 273 from our Kelvin number. Converting Fahrenheit to Celsius and Celsius to Fahrenheit is a little bit different. We're going to use the 40 rule. Okay, so let's convert 25 degrees Celsius into degrees Fahrenheit. The first rule is to add 40 to the original number. So we're going to add 40 to 25 and get 65. The second rule is that you're going to multiply by either 9/5 or 5/9 depending on your need. Use 5/9 for moving from Fahrenheit to Celsius and 9/5 for Celsius to Fahrenheit. Because we're moving from Celsius to Fahrenheit, we're going to multiply 65 by 9/5 to get 117. The third and final rule is to subtract 40 from your to get your final answer. So we're going to take 117 minus 40 and get 77. So now 77 is our final answer. It's 77 degrees.
Created using Powtoon.